Hey, this is Ben from Bulldog Bikes, and today we are going to be covering some basic applications and uses of the limit for precalculus at Sullivan West. So the first question we have to address is, what is the limit? And a limit is really just a question you can ask yourself about any equation, and that question is, as I get closer to a certain x value for this equation, what does my output of the equation, or my y value, approach? And sometimes that's a very simple question to answer. Like for our first question that we're going to look at, we're going to find the limit as x approaches 1 of the equation x squared minus 3x minus 10. And if we were to look at this equation, it would look something like this. I believe there's a 0 at 5 and 1 at -2. So you just have a parabola. And what we can say about this function is that it's continuous. Like this function in every direction goes on until infinity, and there's no x value that doesn't have a corresponding y value. So if we were to look at where the function is at 1, this value here, if we're finding the limit, we would say that we're approaching it from this direction. We're approaching it from this direction. We want to know, what does this get close to? And in this case, it's really just getting closest to the value of f of x at 1. And to find that, we would plug 1 into our equation, so we'd say 1 squared minus 3 times 1 minus 10, and that would give us -12. So the limit as x approaches 1 of f of x in this case is equal to -12. But we can also take this to apply to harder problems where there's what we can call a discontinuity or a hole in the graph. An example of that would be the equation x squared plus x minus 5 over, or plus x minus 5, my bad, over x plus 3. And if we were to take the limit as x approaches -3, we would actually have a problem looking at this graph. Because if we were to draw it, we would see that there's really a hole in this graph at -3. And in this case, when we're taking the limit, we're still asking what it approaches to, and I like to think of it as we're trying to find the value that is inside of the circle, like what number is this hole around. And to do that in an example of a graph like this, what we really have to do is realize that the problem that's creating this hole is the bottom of this equation, because at -3 this is 0 and we can't solve for that. But what we can do is we can simplify this equation to find what the value would be if this graph wasn't discontinuous at -3. And the best way to do that in this case is to factor the top, and we would get x plus 3 and x minus 2 as the two factors. And because that's over x plus 3, we can cancel out the x plus 3 and realize that this equation is the same as x minus 2 with this discontinuity. So to find the limit as x approaches -3, we would plug -3 into this equation of x minus 2. So we get -3 minus 2, and that's equal to -5. So the limit as x approaches -3 in this equation is equal to -5. There's also some equations, though, where a discontinuity can't really be taken out of it. Example of that can be a piecewise function, like this one here, where we have 5 at x is greater than 3, but at x is less than or equal to 3, we have the equation x minus 1. We put that in this notation to make it a discontinuous graph, and we're to ask what's the limit as x approaches 1. Well, if we draw, we'll see we have a problem, because that looks something like this. We go 1, 2, 3, 4, 5, and over 1. Actually, we want to take the limit as x approaches 3 now that I think about it to show this problem. So at x is 3, we have a circle here and a line going over, and that's our equation 5 there. And below that, there's 1, so it looks something like this. And if we were to look at this, we'd see that, oh look, it doesn't really approach anything here because there's a big gap in the equation. So in this case, there's not really a limit there, because if you approach it from this direction, you're getting closer to 5, but if you approach it from this direction, you're getting closer to 2. So we can't say that there's a limit here, but we can do something called the left and the right-handed limit. So what we can say is that the limit of f of x as x approaches 3 from the left hand, or the negative direction of the graph, would be equal to 2. And if we were to take the limit as x approaches 3 from the right hand of the graph of f of x, we would say that it approaches 5, or it's equal to 5 if you take this limit. So you have a limit from each side, but you don't have one limit, and there's not one limit because these two things aren't equal. And lastly, let's take a look at a slightly more complicated equation. For example, this one is x squared over 3 minus 3 divided by x minus 3. And we're going to take the limit as x approaches 3. And if you look at this one, you're going to say, like, wow, that's a lot of numbers. This is, not something that's really intuitive to look at and see what's going on. But again, what we really just need to do is figure out how to make the bottom not equal to 0. So in cases like this, a lot of times, the first thing to do is create a common denominator on top. So if we were to look at this, we could say x squared, like we could make a common denominator of 9, which would make sense, over 3 minus 9 over 3. And now we have a common denominator for these two, so we can put them together and we can get x squared minus 9 over 3 divided by x minus 3. So that's the old frame there. Then if we were to, that's minus 9 there, so then if we were to take this, that can become x plus 3 and x minus 3. Now hopefully you see where this equation is starting to go. If we put that over 3. And then to take this, to divide this out, we would invert and multiply, so that would be multiplied by 1 over x minus 3. We can cross these out and we get x plus 3 divided by 3. And now if we look at it, we can say, oh, we actually can take the limit as x approaches 3 here. Because as x approaches 3 here, you can put 3 into here and you get 6 divided by 3, which would give you 2. So the limit at this place is 2 for this equation. I hope that helps, and thanks for watching.